Hello, welcome back to Organic Chemistry. Today we'll be talking about the aldol reaction. Specifically, we'll be talking about the intramolecular aldol reaction, where we're going to have a carbonyl and an elate on the same molecule are going to react with each other, right, to form a new molecule. And so we're going to look at two different examples of this intramolecular aldol reaction, where we can draw them out like this. And again, when we do aldol reactions, it's under basic conditions. So we'll have our NaOH with our water. Okay, we can have this type of carbonyl species. I can draw another one like this, and again, under the same type of conditions. And the mechanism for both of these is going to be the same mechanism, right? Only we're going to get slightly different products, right? Now, as we look at this, we're going to make an elate on one side. The elate's going to then attack the carbonyl, right? As it does that, we're going to form what? We're going to form a ring. And what we have to remember about rings is we want to form the most stable ring possible, right? What's the most stable ring that we know about? It's that 6-member ring, cyclohexane. What's the next most stable? It's cyclopentane, a 5-member ring, right? And that's what we're going to form here. This one here is going to form our 5-member ring. This will form our 6-member ring. And what we're going to do is we're going to form our ring like this. It's going to have our dove on here. And we're going to have that structure there, right? And so we can see how we're going to make the enolate will come down and attack this carbon. The carbonyl used to be a carbon. And we're going to make that, again, that alpha, beta, unsaturated carbonyl, right? Same thing with this one down here. It's a little bit longer of a chain. We're going to form a similar type of structure, right? Where it's going to make an elate here. It's going to attack this carbonyl. And we go through the same mechanism we saw for the aldol condensation, right? Where we end up with what? Our alpha beta unsaturated carbonyl. Okay? We'll go ahead and do the mechanism for our 5-member ring. The 6-member ring is the same type of mechanism. Okay? So we'll just focus on the 5-member ring for the mechanism. So let's go ahead and do our mechanism for that 5-member ring. Just a little more room. Again, by now you should get pretty comfortable with doing the aldol reaction, right? Oops, we'll use a base. Should get pretty comfortable with this now, right? We know that we're going to take our base. It's going to react with the alpha carbon hydrogen. We're going to make that enolate. Right? We've seen this multiple times. You should start becoming automatic, right? All right, so we've made that enolate there, that negative charge on that carbon, right? This carbon is going to do what? It's going to come ahead and it's going to attack here and cause these electrons to go out, right? We've seen that before. We've seen that multiple times, okay? Notice here, we'll count our carbons. Let's count our carbons and keep track of everything. 1, 2, 3, 4, and 5. So we can see here is what's happening. Carbon 5 that has the negative charge on it is going to attack carbon, or carbon 1 is going to attack carbon 5, okay? Carbon 1, carbon 5. So we count 1, 2, 3, 4, 5. It's going to make a 5-membered ring, okay? 5-membered ring. So let's look at that. So we're going to get our 5-membered ring. And since we know it's going to be a 5-membered ring, I'm just going to go ahead and just draw a 5-membered ring. And I'm just going to put the carbonyl right here, right? This is going to be carbon 2, right? We know carbon 1 is going to attack. And so what I'll do is I'll just draw that right here. It's carbon 1 is going to attack. So 1, 2, 3, 4, and 5. We know carbon 1 here, which was the enolate, is going to attack carbon 5, which is what we're doing there, right? What else is attached to carbon 5 that I didn't draw in? We know on carbon 5 there's what? There's going to be a methyl group here. And there's going to be an oxygen group on there. So we'll draw that there. And we'll draw this here. Okay. Counting your carbons is a great way of kind of keeping track of things, right? By counting our carbons, we kind of can figure things out. It makes things a little bit easier, right? I knew there's 1, 2, 3, 4, 5. I knew it was going to be a 5-member ring. So I just drew a 5-member ring. I didn't just drew a 5-member ring, didn't worry about it. But I knew where things were at. I knew at number 2, there was going to be a carbonyl. I knew carbon 1 was going to make a bond with carbon 5. And I knew on carbon 5, there's a methyl group and an oxygen on there, okay? So I was able to keep track of everything. And then 3 and 4, they're just along for the ride. They're just here. They're not doing anything, right? Just part of the chain. Okay, now we made this structure here. Then we're going to react to what's going to happen next, as we saw before. We're going to protonate it with our water. So it gets protonated. We get our carbonyl. Right? And we get to the species here. But remember, as we saw before, are we done? We're not quite done yet, right? We still have one more step. Make this a little bit smaller. We have one step left, right? Remember that last step we had? Remember, this is under basic conditions. We have OH in there, we have water in there. So our base is going to come in. And what's going to do what? Remember, it's going to deprotonate here. And it's going to kick off our OH group. Because again, that driving force is we want to make the alpha beta unsaturated carbonyl. That's important, right? Alpha beta unsaturated carbonyl. That's going to be our stable compound. We'll draw it down here. Whoops. Draw my carbonyl, draw my double bond, and we'll draw in that group there, right? So look what happened. We were able to make our alpha beta unsaturated carbonyl. We did our intramolecular aldol reaction, where I was able to take this hydrogen here, pull off this hydrogen, make our enolate. Enolate then attacked itself, this carbonyl, which then made our 5-member ring. Once it had oxygen here, picked off the proton, which then generated this intermediate here. That, again, wasn't very stable under basic conditions because we could deprotonate this hydrogen, kick off this OH group to make the alpha beta unsaturated carbonyl, okay? We made our 5-membered ring here, right? Now, one question we can think about here is that, well, notice how I pulled off the proton here. Why didn't, I could make an alpha carbon here. Why didn't I pull off that one? Let's look at that, right? Why did I want to make the enolate here? Let's see what that enolate would look like. We'll erase this. We'll draw in our group again. Oops, missing one carbon. There we go. All right. So we're going to add our base in this time. And so notice last time we made the enolate at this carbon. But I have an alpha carbon here as well, right? That has hydrogen attached to it. What would happen? Let's see. Okay, we pulled off it there. Now we made this enolate here. Now what would happen is this enolate then it's going to do what? It's going to attack something, right? It's going to attack this carbon here. But what's our problem here? If we're gonna make a ring, right? But what type of ring are we going to make? If I count the carbons, 1, 2, 3, I'm going to make what? I'm going to make a very highly strained ring, right? If we were to go forward with this, we'd make something like triangle, right? Oops. And that's going to be our 2, that's our 3, that's our 1, and we have a carbonyl here, right? We made this structure here, but the problem is this isn't very stable, okay? This structure here is not stable. It's not stable because we don't nearly see a 3-membered ring, right? It's too strained, okay? That's why we're not going to make our enolate here because this is going to form this structure here, which is not very stable. It's just going to open back up. It's going to fall apart, right? But if we make the enolate here at this carbon here, we're going to generate that 5-member ring, which is actually fairly stable, right? Stable enough that we can form, and that can be a major product, okay? So it's not stable. So not a stable ring, right? So we're not going to make the enolate this carbon. Enolate is not formed. Enolate is not going to be formed at this carbon. We're going to make the enolate where? Enolate's going to be here so that we can give us our 5-membered ring, right? Enolate is not formed at this carbon. Okay? That's why we made the enolate here so that we can get that nice stable 5-membered ring. Okay, 5-member ring. We try to take the enolate here. We're going to make this 3-member ring, which is, again, not a stable ring. It's not very stable. It's going to just fall apart. It's going to open back up, right? We go back this way, okay? So keep that in mind. That's why I pulled off this one. Our stable rings are going to be that 5 and those 6-membered rings. okay, for our intermolecular aldol reactions to form those rings.